So the topic is quadratic functions and quadratic equation. For the general quadratic equation, we have ax squared plus bx plus c equal to 0. So that's the general quadratic equations. And what we want to get here, we want to show how we get the quadratic formula. And we're going to use completing the square method to generate the quadratic formula. So step 1, can we divide through by uh, by a? So we have s squared plus b over a plus c over a equal. Then let's move this one to the other side. So that will be equal to s squared plus b over a equal to minus c over a. So the next thing we want to do now, we want to express the left hand side as a perfect square. So in that case now we are going to add this half of this, the square of the half of this to both sides. Okay, so add what? Add half of this will be b over 2a, the square of it. Add it to both sides. Add this to both sides. Okay, and make the left hand side a perfect square. So we are having now s squared plus b over a, okay, then plus b over 2a whole square equal to b over 2a, okay, that's what we are adding to both sides. Then in that case now we can have this will turn to perfect square. That will be, and if we turn to perfect square, that will be one of this here, then one piece here, or one of these also here, b over 2a all square. That's a perfect square. Then you can solve this one. This will be equal to b squared over 4a squared minus c over a. So that's what we have there, and which will be, if you continue this one, this will be 4a squared. That will be equal to b squared minus, how many 4 in this one? That's 4a times c. That's 4ac. Okay, so in that case now, we can now take the square of both sides, and that will be equal to x plus b over 2a equal to plus or minus square root of b squared minus 4ac over 2a. Okay, and that will give me x will now be equal to this one will go to other side. Then I have minus b over 2a plus or minus the square root of this. No, this is a fraction, which means the square root of the numerator, the square root of the denominator. What I have there is 4a squared. Sorry for that. This is 4a squared. 4a squared. Okay. So that will be square root of this, b squared minus 4ac all over the square root of 4a squared. That's 2a. Finally, s is equal to 2a minus b plus or minus b squared minus 4ac. So this is what we call the quadratic formula. It enables us to solve quadratic equations and also to investigate the dependency of the roots on the relative values of a, b, and c. Okay, so that's that. The next thing we want to see now is what we call discriminants. Discriminants. That's what we want to discuss now. Discriminants. And what is discriminants? For the quadratic equation, d, which is the discriminant, is equal to b squared minus 4ac. That's the value for discriminants. Okay, so we want to see several natures of this. We want to see some conditions. If discriminant is greater than 0, what do we call it? Okay, if discriminant is greater than 0, we're going to have real values. Okay, if it's equal to 0, we're going to have that. We call it equal roots. and if your discriminant is less than 0, we call it no real roots. When your discriminant is equal to 0, you're going to have real values, okay, and that will be true values, two real values. When your discriminant is equal to 0, we have what we call the repeated roots, or you call it equal roots. And when you have discriminant less than 0, you're going to have no real roots. In that case, it will be a complex number. So let's make note on that, on those three conditions. Condition number 1, discriminant greater than 0. Discriminant greater than 0, we say we have what? We have real number, real numbers. We have real numbers and obtain two distinct real roots. Okay. Condition 2 for discriminant equal to 0. We have one repeated root. One repeated root. We call it equal roots. We have equal roots. Then the last one, discriminant less 0. We have has no real roots. These are the three conditions for discriminants. Okay. The next thing we want to look into now is to play with questions on these three conditions. For yeah. So this is what we have here in this question. Find the values of a for which the equations which we have here has equal roots. And don't forget, for the equal roots, we said that discriminant will be equal to what? 0. Okay. Then, which means b squared minus 4ac equal to what? Equal to 0. So in this case now, what is our a value? Our a value will be the coefficient of the s squared, which is 3a plus 1. That's the a value. Then the b value will be equal to what? A plus 2. Then the c value is 1. So let's substitute that. That will be equal to a plus 2 square plus minus 4a. A is 3a plus 1. Then 4ac times 1. 4ac times 1 equal to 0. Then we can do the expansion, which if you expand this one, I've done that I've done these lectures on equation 1 involving one unknown, so you can check the video and learn that. So this will give me a squared plus 2 here, a times b, that's 2a, okay, then plus b squared, that's 4, and then this will give me minus 12a minus 4 times 1 minus 4 equal to 0. So that's what we have there. Then that will be equal to a squared plus 4a plus 4a plus 4a plus 4 plus 4 minus 12a and then minus 4 equal to 0. This plus 4 and minus 4 will cancel out. Then we have minus 4 plus 4 we cancel out. We have a squared minus plus 4a minus 12a, that's 8a equal to 0. So in that case now we can factorize a, so a into bracket a minus 8 equal to 0. So a is equal to 0, a is equal to 0, or a is 8. So that's that on that question. Yep. Show that the root of the equation, this equation x minus a bracket x minus b equal to k squared, and always real if a and b, a, b, and k are real. So this is very simple. What we do first is for us to do the expansion of this, which will be equal to this one times this one, that will be s squared. Then this one times this one, that was minus x minus bx minus bx minus bx. Okay, then this one times this one, minus a x, and then minus a times minus b, that's a plus ab. Okay, then we can equal to k squared. Okay, so that will be equal to s squared minus bx. We can factorize this one, this two. We can factorize that. This is common there. And factorize that. That will be equal to x is here. Take it out. Then you have b here. The minus is already taken outside. So minus times minus. That's a plus. Then we have what? We have a here. Then plus ab. Then let's move this one to the other side so that it will follow the equal to what? Equal to 0. So here we can get our here, we can get our b, and we can get our c here. And don't forget, it says always real. So if it's real, it means that the discriminant is greater than what? Is greater than 0. So what we do now is for us to do the imputations. Okay, for that, my a is what? Our a is 1, coefficient of s squared. I didn't even explain that to you. If you have, look at your general quadratic equation. Okay, the attachment to your s squared is what we call the a. That's your a. The attachment to your x is b, and the one that has no x is a constant. That's your c. Okay, so the attachment here is 1. The attachment to the coefficient of x here is minus. We can ignore that because that's minus. B is what? B is b plus a. The minus is of no use because I'm going to square it. I'm going to square the b square. And then the c is ab minus k squared. So let's quickly do that. B squared minus 4ac is greater than 0. So that will be equal to b plus a. Okay. If I put minus there and I square it, that's what I was telling you. Putting the minus here is of no use because it's going to cancel out. So this is your b minus into that. Then plus minus 4a. Your a is 1. Excuse me. Then c, that's ab minus k squared. So that's that. Greater than 0. Greater than 0. So then the next thing to do is also expand these b plus a. If you expand that, that will be b squared plus 2ba, 2ab. This is b times a, that's ab times that 2. And then plus a squared plus a squared. Then expand this one. So that will be minus 4ab minus 4ab. And then minus 4 times minus k squared. That's a minus k 4k squared greater than 0. So that's what we have in that case. And then plus 2ab minus 4ab. That's minus 2ab minus 2ab minus 2ab. Then plus b squared plus b squared plus b squared plus 4k squared greater than 0. Okay, this one turn to perfect square, which is equal to what? A minus b squared. This one, yeah, that's perfect square. A minus b squared plus 4k squared greater than 0. So that one is done. Then the next thing to do is to move this one to the other side. So a minus b squared is greater than minus 4k squared. Okay, so that is that on that case. that's that on that case. And the only thing we have to just make a note is that we'll be able to express the discriminants as the sum of the square of two real number. So we're able to sum of the square of two real number, one here and there. Yeah. So we have done that are always real. Okay. Show that the root of the equations are always real if A, B, and K are real. So that's done. We have succeeded to express uh, d as the sum of the square of two real numbers. Okay, let me just make that note on this on that note. Okay, we'll take the next question. Let's look at the questions there. Question two, another questions. Find the value of lambda for which the roots of the equations. That's the question we have here. S squared minus 3 lambda plus 1 x, and then this one real. And don't forget that the conditions real. So for real roots, we know that discriminant will be greater than what? 0. Okay? Which will be equal to b squared minus 4ac greater than 0. Then we know that our b in this case is minus 3 lambda plus 1. And I've told us that there's no need to indicate the minus because we're going to square it. So it's going to go. So that will be 3 lambda plus 1 squared. If you want to put it there, no problem. So this is your b. This is your b squared. Then minus 4a. My a is 1. And then my c, I need to do the adjustment here. This equation will be equal to, my c is lambda squared minus 5 lambda minus 1. That's my c, because the equation must be equal to 0. So what we did is just s squared minus 3 lambda plus 1 x, and then plus lambda squared minus 5 lambda minus 1 equal to 0. The equation must be equal to 0. So you have to bring this one to the left hand side. So that's our c for ac greater than 0. Okay, so let's expand this. To expand this, this will be 9. This will be 9 lambda squared. When you square the minus, it will go. And this will be 9 lambda squared. A squared. That's 3 squared lambda squared. Then plus 2 invisible 2 times a times b. 3 lambda times 1. That's 3 lambda. Then plus b squared. That's 1. Okay, that's 1. I've done that. Then this one will be equal to minus 4 times 4 lambda squared. I have that. Then minus times minus, that's plus 4 lambda times 5 lambda, that's 20 lambda. That's 20 lambda. Then minus 4 times minus 1, that's plus 4 greater than 0. So that's what we have there. Then the next thing for us to do is to collect the lifetime. We have 9 here, lambda square, 4 here, lambda square. So that will give me 5 lambda square. 9 minus 4, 5 lambda square. Then this is 6, 2 times 3, that's 6 lambda. 6 lambda plus 20. That's plus 26. Plus 26 lambda. Okay, then I have plus 1 plus 4. That's plus 5 equal to what? Greater than 0. So that's what we have there. So what we do now, on factorization, I think we have also done that in one of our videos on the equation involving one unknown. You can watch the video and get more and get an in-depth knowledge on factorization. But I'll still repeat that. So this will just be this one times this one. That's 25 lambda square. Okay, that's a plus 25 lambda square. The two factors of this that can give us 26 plus 26, that's 25 and 1. 25 and 1, that will be plus 25 lambda and that and lambda. So so these two now will now replace the middle one. Okay, and when you multiply these two, you get the product here, 25 lambda square. So we now have 5 lambda square plus 25 lambda plus lambda. okay, plus 5 greater than 0. And you can do the pairing, pair. So 5 lambda is common here. And then you open lambda plus 5. And then here, lambda and 5, 1 is common. And that will be equal to lambda plus 5 greater than 0. So when you factorize these two expressions, must be the same thing. So that will be 5 lambda plus 1, 5 lambda plus 1 into bracket. Take one of these two common expression, lambda plus 5 greater than 0. So that's that on that. And lambda will be equal to, this is equal to 0, this is equal to 0. So lambda is equal to minus 1 over 5 or minus 5. So that's that on lambda. That's that. You can also use a calculator. Just probably you may miss 1 marks. Okay, so that's that on this question. It's very simple. The only thing you just do is just to do the correct expansion here and do the arrangement. So I want to say, if you are new on this channel, please hit the subscription bell so that as we upload, you get notification.